Saudi Arabia holds nearly unimaginable wealth, but it completely lacks the one resource required to naturally sustain a population. Out of all the countries on Earth, it is the absolute largest without a single natural river. To survive in this environment, the nation historically relied on fossil water. These are ancient aquifers buried deep underground, reservoirs that took millions of years to fill, and once pumped to the surface, will not replenish in our lifetimes. In the 1970s, the Saudi government decided to heavily subsidize domestic wheat farming. The logic was straightforward: grow their own food, and they wouldn't have to rely on foreign imports. This chart shows the rapid explosion of agricultural water usage triggered by those subsidies. By 2003, farms were draining a massive 85% of the entire country's water supply. The actual scale of that drain was mostly hidden underground. It wasn't until NASA launched the GRACE satellite mission that the true cost became visible. This line chart tracks the satellite's findings between 2002 and 2016, showing a steep, unsustainable drop. The country was permanently losing 2 trillion liters of ancient groundwater every single year. Faced with these numbers, the government abruptly shut down the wheat program. By treating a finite emergency reserve as an endless supply, they forced their own hand. The country now had to either run completely dry or figure out how to manufacture a functioning water cycle from scratch. This map outlines the solution they landed on: a 12,000-kilometer artificial river network. It is designed to transport 9.4 million cubic meters of fresh water daily. Because surface water would evaporate in extreme heat, these massive anti-corrosion pipes are buried entirely underground. Since there are no inland rivers, every drop of this water originates at the coast, pulled directly from the Red Sea and the Persian Gulf. To make ocean water drinkable, you have to separate the salt. Initially, the country relied heavily on a brute force industrial method called multi-stage flash distillation. This schematic details the process. Seawater is boiled in massive steel tanks, then moved through a series of chambers. By steadily dropping the pressure, the water continues to evaporate even as it cools. The resulting steam is condensed into pure fresh water. Boiling billions of liters of ocean water certainly works, but it requires a staggering amount of thermal energy. To expand the river network, they needed a method that produced the same output without burning through so much fuel. That led to a massive pivot toward reverse osmosis, a technology directly inspired by how biological cells filter fluids. Immense mechanical pressure forces salt water through ultra-thin polymer membranes. These microscopic pores block 99% of salt and viruses, letting only pure water pass. The efficiency gains are massive. Modern plants need just 2.8 kilowatt-hours to produce 1,000 liters of water. But manufacturing the water at sea level only solves the first half of the equation. Delivering it to the population is a severe logistical hurdle. This elevation chart illustrates the physical friction of their geography. To supply inland communities, water must be pumped uphill, scaling mountain ranges up to 10,000 feet high. Driving those massive pumping stations 24 hours a day consumes 9% of the nation's total electricity. Defying gravity across a desert continent turns water from a natural right into a permanent, immense tax on the national power grid. And all that filtration leaves behind a severe ecological footprint. Filtering 9.4 million cubic meters of fresh water daily leaves you with about 329,000 tons of leftover salt every single day, concentrated into a dense, superheated liquid called brine. Pumping this heavy, hot brine directly back into the ocean spikes local temperatures and salinity levels. Over time, this chokes out marine life, creating vast underwater dead zones along the coast. To mitigate the damage, engineers are currently building deep-sea multi-diffusers to safely scatter the salt over a much wider area. There are even proposals to mine the brine for valuable rare earth minerals like magnesium and potassium, turning the toxic waste back into an asset. They have to solve this because they are doubling down on the infrastructure. By 2030, the government plans to meet 100% of the country's water demands through this artificial network. Saudi Arabia has proven that with enough capital and engineering, you can override your own geography. But in doing so, they have traded the natural water cycle for an industrial one, locking the survival of an entire nation into a high-stakes machine that can never be turned off.